Unit 12B, one-parameter hypothesis tests for mu when sigma is unknown. These are called t-tests. We can do a t-test using either the critical value approach or the p-value method. We'll start with the critical value method. According to a nationwide report, U.S. workers averaged 25.1 minutes to commute to work each day. The mayor of New York City states that workers in New York City average less commuting time than the national average. To test the mayor's statement, a random sample of 33 workers in New York City is selected, and the mean commute to work was found to be 24 minutes with a standard deviation of 8 minutes. Do the test at the 1% level of significance. Let's make a picture of the information we have. The population of interest is all the commute times for New York City workers. And we're interested in the parameter mu, the average commute time. We're going to perform a test by taking a sample of how many workers? Well, the sample is going to be 33 workers, so the sample size, n, is equal to 33. The average for the sample was found to be 24 minutes with standard deviation of 8 minutes. That means that standard deviation came from the sample, so it's S. Sample standard deviation was 8. And we're going to do the test at the 1% level of significance. Because we have S, that tells us we're going to be performing a t-test. Had we had sigma, then that would suggest a z-test. But we're doing a t-test. Just as with a z-test, with a t-test, we'll be using a t-curve. And we're going to assume the null hypothesis is true. That means our x bars are going to be normally distributed with mean mu sub naught. Now, if the x bar in our sample comes out to be very big out here to the right, then that would support the alternative hypothesis, which says that mu is bigger than mu naught. So we would be supporting H1, and that means we're rejecting the null hypothesis. So if we're far enough out to the right, how far? Well, this tail is going to have area alpha, and that means that T critical is going to be the boundary separating the rejection region from the rest of the curve where we do not reject H naught. Similarly, for H1 mu less than mu naught, think of the less than sign as an arrow pointing to the left. That tells us it's going to be a left tail test, where alpha would be on the left side. This is minus T critical, and we need to find the critical value of T to do the test. When H1 is not equal to, just as before with the z-test, with the t-test we're going to have two tails, two rejection regions. Each one has an area of half of alpha. So we would have two rejection regions, each tail. And we have to find Tcritical and minus Tcritical, which by symmetry would be opposites of each other. The picture on the left summarizes the information we have so far. We'll be doing a t-test. So whenever you're using a t-curve, you have to identify the curve with degrees of freedom. So in this case, degrees of freedom, which equals 1 less than the sample size. Sample size is 33. 33 minus 1 is going to be 32. So we're going to be using a t-curve with degrees of freedom 32. Next, we have to establish our hypotheses. To do that, you read the problem over again and look for the claim. Look for the claim or the belief that we're going to test. Well, the problem says workers in New York City average less commuting time. The commuting time is less than the national average. So that says mu is less than, and because equality goes in the null hypothesis, we have to be in the alternative hypothesis, mu less than 25.1. So that's going to be our claim. And then the same number, 25.1, has to go in H0. Because this arrow, if you want to think of it as an arrow, less than sign, is pointing to the left, we're going to have a left tail test. That means the area of this left tail is going to be alpha, or 1%. And this is where we're going to reject H0. That's our rejection region. If we wind up here, this way, then we do not reject. H0. And now the next step would be to find Tcritical, which on this side we know has to be negative. So how do we find Tcritical? Well, with Z-critical, we could use a chart like the one shown here. And we had a simple chart because there's only one standard normal curve. We will not have a chart like this for T-critical because there are infinitely many T-curves. So there's not going to be a simple method like this for getting T-critical. What we can do to find T-critical is to use a T-table like the one shown in this picture. The way this works is we have degrees of freedom in this column, and across the top we have right tail areas, and in the body of the table we have the T-scores, or for us, T-critical. So this chart, if you have this area of this right tail, that's related to this boundary point, T-critical. Well, we have a left tail, but let's use that one. The area of this left tail we know is 1%, 0.01, and we also know, I didn't write it here, degrees of freedom for this particular curve was 32. So we have degrees of freedom and we have the area of the tail. So let's use the chart. Go to degrees of freedom column, go down to 32, down there. The area of the tail is 0.01, so going across this row, 0.01 is right here. So we go down that column, across this row, and we'll come to this score right there, 2.449. So 2.449 would be Tcritical, except on this side we know zero's in the middle for a T-curve. So this has to be negative 2.449. The second way of getting Tcritical is to use the TI-84 calculator. Press second distribution, then go down to number 4, inverse T. The way inverse T works, it's based on the area below. So area below is T, and this would be the area to the left, area below. Now we know this area below is 1%. And we know degrees of freedom is 32. With this test, when you press enter, you're going to see this menu, and you have to put in the area below, which is 0.01, then put in degrees of freedom, navigate down to paste and press enter. If you have an older calculator, you'll just put in the area below, comma, degrees of freedom, and press enter. Press enter again, and the answer will be shown. So Tcritical, and this gives you the negative sign, negative 2.45 rounded off. Now that we have Tcritical, we can put that into the picture, and we have to find T observed. We're going to change X bar to a T-score. With a Z-test, we standardize X bar. With a T-test, we studentize X bar. So we're going to change this to a T-score, X bar. So how do we do it? To find T observed, we put in X bar, which was 24, and we said that mu was 25.1, S was 8 over root n is 33. Now if we do that computation, on top we get negative 1.1, and in the denominator 1.392 and so on. If we divide those, we get 0.79 rounded off. So there is T observed, and now we have to see, where does T observed fit in this picture? Well, 0's in the middle. This is negative 2.45, so negative 0.79 would be someplace in here. It's in the do not reject H0 part of the curve, so we would say we do not reject H0. This is the case where our result is not statistically significant. We have made our rejection decision. We do not reject H0. Now we have to make the statement about the claim. The claim in this case was H1. If we reject H0, then we have enough evidence to support the claim. When we do not reject H0, we do not have enough evidence to support the claim. So therefore, we would say at the 1% level of significance, there is not enough evidence, insufficient evidence, to support the claim that the mean commute time is less than the national average. We could perform this t-test using the p-value approach. The p-value approach is a little difficult to use when you do it by hand using the t-table. So let's look at how we do it on the TI-84 calculator. We press Stat, Tests, and then number 2, ttest. We're going to be inputting summary statistics, so we highlight statistics, and then we put in mu naught, which is the value of mu from H naught, and put in the sample mean, the sample standard deviation, the sample size, and then if you remember H1 was mu less than, so we choose the less than symbol, highlight that, press enter, and you can press either draw or calculate. I pressed calculate. Draw would give you the picture, but in any case both of them would give you the p-value. So we're interested in the p-value. The calculator uses the p-value approach, and we get the p-value is about 22%. Alpha is 1%. 22% is greater than 1%, so p is greater than alpha. Because p is greater than alpha, we do not reject H naught as we had before. This is the end of Unit 12B.